Hello and welcome to Sherlock's Tutorials, your trusted tutor. So today we're looking into rationalizing the denominator, that is when the denominator is a surd. So what is a surd? So a surd is any number that is in a square root and it is not a perfect square. For example, a square root of 2. 2 is not a perfect square, so the square root of 2 is a surd, the square root of 3 is a surd, the square root of 7 is a surd, and so on. As long as that particular number is not a perfect square and it is in a square root, that number is called a surd. So then, how do we rationalize surds? So here's a quick example before we go into solving. So if you have a divided by, let's say, the square root of b, and given that b is not a perfect square, what then do you do? So when you have this scenario, all you do is you always multiply by 1. But this 1 is actually represented in another manner, because if you want a over root of b, instead of just saying times 1, you're going to multiply by root of b over root of b. Why? Because root of b over root of b is actually 1. So you haven't changed this particular expression at all. So then you say a times the square root of b will be a square root b. And then b times, square root b times square root b would just be b. So that would be one way of solving this. And what if then the denominator is a binomial with a surd in it? For example, you have a over, let's say, c plus square root b. You still multiply by 1, but this one in this case is represented like this. It will be c minus square root of b all over c minus square root of b. The reason why we're doing this, you will see that the bottom part will actually represent a difference of 2 squares, which is easy to deal with. So this will be a, open bracket, c minus square root b. You will be able to distribute the a when you want to, and then this will actually be c squared minus b, which is a difference of 2 squares from c plus square root b, c minus square root b. So it becomes a difference of 2 squares. So then these two approaches are the most used approaches. If you know any other, please let me know. I'm willing to learn from you as well. So if you want to rationalize, here's a good example then. Let's say you want to rationalize 1 over 5. Using the tips that I gave you at the top there, you can pause the video and see if you'll get the same answer as I will. So 1 over square root 5. So what I'm going to do then is just rationalize it by multiplying by root 5 over root 5, which is just multiplying by 1. The answer will be square root 5 over 5. There we go. And this is fully rationalized. So we do not want the denominator being a surd. And same applies this side. You can just multiply by square root 11 divided by square root 11, and you'll get square root 11 over 11 as your answer. All right, if I just want to extend on this, there's a maths trig complement that always looks like this. What do we call this? Root 2 over 2. But where does it actually come from? 1 over root 2. Right? So you normally see this in trigonometry special angles. So where does the root 2 over 2 then come from? If you rationalize this, you're going to multiply by root 2 over root of 2. And your answer is going to be root 2 over 2, which is what you normally use as a special angle. All right. Sometimes, let's say you have something like this. Let's say you have square root of 2 divided by the square root of 3. If you rationalize this, you only rationalize the denominator. So this will be square root of 2 times 3 inside the same square root divided by 3, and this would simply be square root of 6 over 3. All right. So that is when you just rationalize with one term in your denominator. Let's see if you're rationalizing with 2 terms in your denominator, what happens. Okay, so let's start with this. We realize we want to make the denominator to be rationalized. So it will be 3 plus square root 5 over 3 minus plus square root 5, sorry, because it needs to be 1. So multiplying by 1, then all I will get is 1 times of 3 plus square root 5. It will just be 3 plus square root 5. But then the denominator is actually a difference of 2 squares that comes from 9 minus 5, which will then give you 3 plus square root 5, all divided by 4. For those who are interested in how I got to 9 minus 5, let's test this. You have 3 minus square root 5 multiplied by 3 plus square root 5. When you distribute and you say 3 times 3, to get your answer, you'll get a 9. And then you go 3 times a positive square root 5. You'll get a positive 3 square root 5. Then you say negative square root 5 times 3. You get a negative 3 square root 5. And then you say the negative square root 5 times the positive square root 5. You'll just get a negative 5. Right, which is a beautiful one. And then you can obviously see from here forth that that cancels that, and you're only left with the 9 minus 5, which is what we got. There is our denominator. Okay, remember to always pause your video and try to do it on your own. Especially now, I'm doing number 2b. You can pause your video and see if you'll get the same answer. I'm multiplying by 4 minus root of 3 divided by 4 minus root of 3. I'll get a 2 times of 4 minus root of 3, which is multiplied with a difference of 2 squares of this. So that 4 squared will be a 16, minus that root 3 squared will be just a 3. I can then distribute the 2. I'll get an 8 minus 2 root of 3 divided by 13 is my answer. All right, this becomes very simple as we do more. Okay, let's do the last one for these ones. Multiply by 5 minus plus root of 2 divided by 5 plus root of 2. This will basically give you a 6 open bracket 5 plus root 2 divided by 5 squared, which is 25, difference of 2 squares, remember, minus square root of 2 squared is 2. So you distribute that, you will get 30 minus 6 root 2 all over 23. And there you go, you're done. All right, let's see what happens if we make it look like this. So sometimes you might need to simplify before you rationalize it further. So in this case, you'll realize that before I rationalize, even though rationalizing right away will still work, it's just that it will take long. This can first be 1 over, this is a perfect square of 3 minus 2 root 2. Okay, the square root of 8 is known as 2 root 2. Now, that means I'm going to multiply by 3 plus 2 root 2 divided by 3 plus 2 root 2, which represents my 1. So now I'll have 3 plus 2 root 2, and a perfect square of this, you need to be very careful because you need to square the 3, which is a 9, minus the difference of 2 squares of this, minus, if I square the 2, I get a 4. The 4 will be multiplied by the 2 inside here. So it's basically, let me do it like this. This is 4 times 2. Because if you square 2 root 2, it's the same as squaring the 2 alone and squaring the root 2 alone. And that should give you a 4. And that cancels that and should give you a 2. So eventually that should be an 8. So we can remove that and put an 8. Okay, so this is an 8. Beautiful. This will be 3 plus 2 root 2 over 1, which is simply 3 plus 2 root of 2. And this is fully rationalized. All right. And if we look at the other one, that side, let's see what would have happened here. We multiply both sides by square root x plus square root y and square root x plus square root y. That should give us square root x plus square root y divided by, this is a difference of 2 squares coming from x minus y. Because you're squaring the square root of x, you get x, and then minus squaring the square root of y, you get y. All right, so this is your final answer. I hope you enjoyed this and come back for more. Have a beautiful day. Goodbye.